Welcome to a new test and teardown video. Well, this one is actually going to be a repair video because I got this one already as defective. It is called FMG 10, a mobile radio test set, and it can do basically all the stuff you need to test your radios. Transmitters, receivers, modulation. It can measure the power you're transmitting with. We got audio generators. We got everything in one unit. So I look very much forward to see if I can figure this out. I was told it was the power supply, and look what I got, a schematic of the power supply. So it was a little, hey, can you fix this? And here's a little challenge. So I've already been looking at the power supply before I even opened this unit. And here's what I see. We got a traditional mains transformer, rectifier, linear regulator, battery charging, and a little relay switch over, running off battery and not. And I think this has something to do with a special hold set reset. I actually don't know exactly what they're doing here. It looks a little bit like it's two relays, but it's also called K2 and K2 here. So I don't know exactly what's going on here. But then the 12 volts will come in here, right? Into a switch mode power supply. So this is a quite normal flyback converter. It's not super complicated, so I actually think this is where I will find my problem and my little challenge for tonight. So let's just start and open this unit and see where is the power supply. So now we are inside. I was able to unscrew the power supply that is mounted here on the rear panel. It looks a little bit like this. It's actually quite heavy, and I see some wires here, the red and the black here. That will be for the battery, and you see the battery wires down here. They're just hanging freely, so they can short circuit to all sorts of electronics down there. This can't be good. And then there is a fuse. I mean, it could have been quite smart to remove that fuse. So this is not hangly-dangly around this place. Getting voltage, charge voltage on this and going into all the electronics down there. And this is probably what's causing all sorts of problems as well, right? There's a little speaker down there, and here was this cable for the rest of the unit. And that is, it was connected here. Power supply and stuff like that. And let me see if I can get this out. And I'm actually having a fight of the big ones getting this whole unit out the case. It seems like some of this metal kind of locks, so I didn't figure out yet how to pull it out. Maybe I'm just a little bit too nice, but I don't want to pull so hard so I break something, but it's just not coming out. Finally, we got a winner. I was able to figure this out. It's actually this one. It kind of digs itself into all sorts of stuff here. It's just, there is no free space to come out here. So it's, why the heck didn't they make this a little bit smaller? You can see it's not me making all those marks. Can't be that, right? And then there is, of course, the power supply we're going to play with. And here is a cable for the speaker. Why isn't there a little connector here you can pull? But okay, you need to desolder the speaker. So that will be the speaker amplifier here. Okay. Or maybe it's somewhere else. I think this is here. This type of capacitors, they are world famous for failing, so that is definitely something I want to look at. All the relays, and here we got some more. Ooh, here is the switch mode power supply. Here is the power supply. I've been playing around with this for a little while, and it's really good. I got the schematic. I want to show you a little bit how this schematic works. This actually works. So here is a 14 volts regulated power supply, and this charges the battery. Okay, so when there is voltage applied, it will turn on this relay and then it will start the charge. And this is the charging resistor. So when there's no power here, it is actually possible to get the battery power via this relay, right? So here it's not activated, and then you can go into battery mode, or you can use external DC input. We got those banana plugs on the back. So there's also a possibility. And then you have voltage applied here, right? So this is the on-off switch. Here it is in off state. It's also the same switch. It's a 3-position switch, right? So it's also here. And it says off, on, and charge. And it is shown in off position. So here in off position, you see this resistor here. This is a discharge resistor for this capacitor. So now it says off, and then you crank it on to on. So this DC voltage here goes through this capacitor and activates this relay only for a short period of time, but it's activated. And then there's also a constant battery voltage going this way, ready here on this relay. And see, this relay was active for a short period of time. And here you go. The battery voltage now goes this way to this circuit. This circuit is an under voltage detector, and it will activate this relay immediately if the voltage is more than 11 volts. So battery voltage is okay, fine, fantastic. Let's activate this relay. It disconnects here, but it doesn't matter for us, right? Because we are in this position, right? And then it activates the power this way. And then we have power to our switch mode converter. So that is the power on sequence. And this is exactly what is not working. So I get all this voltage here. All this is perfectly fine. This relay is working. And I do see this pulse, but this is not working. So let's look how it looks here in the real world. Here is this linear power supply and this power transistor. Okay. The 3 transistors in this circuit here. It is right here. The schematic I got is not exactly this version. So there's also a capacitor here, but it's more or less the same circuit, right? Look at this capacitor. This is leaked, and we see corrosion here. And that is why it's not working. So this is stopping this circuit from working. I'll try and show you the bottom side of this PCB. I can actually look in here. I don't know if you can see this, but it's... yeah. I don't know if I can make this sharp. Damn it, it's so out of focus, which is really driving me nuts. But this entire area under that capacitor is completely corroded. How is that possible? How can this acid stuff go all the way through the PCB? I don't understand that, but that is definitely why it's not working. But since we don't want to use the features with the relays, the charging and all that kind of stuff, we don't want to run this unit off batteries and use this outside in the field. We just want to actually remove those relays and just have this regulated power directly to the switch mode. So what I've done is I took a variable DC supply and just connected 12 volts to the switch mode converter, and of course it works. It was adjusted to 16 volts instead of 15. It is supposed to, let's look at that. Here's the switch mode converter. See, there's a trimmer here that is measuring the output voltage, the 15 volts positive, and that was actually 16. So of course the negative was also negative 16. This is just the same windings, so that will be more or less the same. But I got like 12 or 13 volts out the positive 5 volt. How is that possible? If you look at the schematic here, we got 22 ohms and a Zener diode. So this will start loading the output here if it's way too high. So I don't have a component placement. I don't have anything actually beside this paper schematic. So when I'm looking here, the only 22 ohm resistor I can find and this 5.1 volt Zener diode, that is here. And this is the 5 volt inductor. I think it's that one or something. No, 5 volt. Here we are, right? So I think we are maybe somewhere here. So this is the 5 volt. And look at that. Try and look really, really careful on this resistor here. It should be connected to this Zener diode, and this is ground, right? So let's try and look a little bit from the side, and you're not going to believe what I'm talking about here. Let's see if I can show you this. Let me get some light. Yes, here I can show you. See? No track. No track on that resistor. Light is here. Look at that resistor. It is that one, most to the right. That track is missing. How embarrassing. So that was never ever working. So that means you can't run this power supply alone without load on. Then your 5 volts is just gonna skyrocket. I mean, that is embarrassing. Of course I'm going to fix this, and then hopefully I'll be happy about the power supply, and then I can start testing the rest of the unit. And here is my shorts. This is mains actually, and this is the on-off switch. As you see here in the schematic again, this is the mains on-off switch, and then where's the other switch? Here it is. Here is my on-off switch, and it says 6B and 4B. So this is what I've done, 4 and 6B. So that's how it works, and this is of course just the mains. So I'm not touching anything here, right? So yeah, that is what I've done. Removed all the relays and just moved my input to the switch mode converter directly to the output after the current protection. And then it of course works. I just leave everything else so it can be reverted if we wanted to do that one day, but all this crap is just way too complicated and definitely not what we want to do. So the rest of this switch mode converter here is actually quite beautiful and quite nice, and everything here seems to be working, other than I'm not super happy about it's only regulating one of the outputs, and there isn't any super good coupling between the outputs, and 5 volts is like 4.8 volts, and well, this is how it is. So now I'll assemble the power supply and see if the rest works. So I'm actually ready to do the first power up after I fixed the power supply. What I've done here is I just connected the power supply directly to the main unit. But the first thing I spot when I'm looking around in this unit is here at the top. I see more of those capacitors. So, and then I started to look, yes, this unit is full of exactly this type, and they all look exactly like this. Oh no. But I'll try and power this up just for a little while and then see if they run hot or if there's any other. It's probably going to cause a lot of damage, parts like this, right? So this is something we need to address real fast. But I just wanted to see if it's powering on and off here correctly when I move this switch. So here is mains power is applied, and of course nothing should happen, right? And then I crank, yes, and it goes on. 45 watts. And it is not going up or anything bad. Why is it looking like that? This is not so good. Well. Yeah. Why is it looking like that? So we definitely got... Well, I need to play a little bit with all this. This is not good. Yeah, so I just changed the first capacitor up here to a ceramic. So everything should be perfectly fine. But then I started to look a little bit around. What else have we got? So there was a shield plate behind this board. I started to look a little bit for this type of capacitor here. And if you have a little look, I don't know how easy that is to see, but this board is completely full of those capacitors, and they're all completely leaked, and they totally destroyed everything. So look at that. Corrosion is all the way through. No, this is so bad. Everywhere. It's completely corroded, causing all sorts of bad things. Look at that. See? Oh man, this is going to take 1,000,000 hours to replace all the capacitors. This is not within the scope of what I kind of planned for. Yeah, but there's a lot of hours to play around with capacitors, definitely. But I really wanted to have a look inside this big box. I think this is also what is doing the frequency counting and all that kind of stuff. Yeah, look at that. More of those capacitors. You see all the infected components around it. It's just completely corroded. That can't be good. So this is the meter, some amplifiers for meters and all this. You're full of those. So this is the meter that is looking really weird and not doing anything at all. But what I see here, we got some parts, probably just drivers or counters or something like that. LED drivers, right? See? They're just driving all the 7 segments here, and then they're connected to all those shift registers and whatnot. We've got some flat cables going into this box here. Look at that. Via some feed-through capacitors here, and via this cable here that also goes down here to all those feed-throughs. So a lot of cool stuff is in that box. We got, oh, look at that little chain coupling down to here. Some more stuff. Oh, that's just beautiful. What have they done? What is all this? What is all this good for? I mean, why all this? I don't get it. What are we doing here? That is weird. What the heck is going on? Is this just to create some sort of a steady feeling? Because there is a really, really nice feeling to this. So this is done by all these mechanical parts. What do you know? And this goes up to the main tuning, of course. Huh. Yeah, I gotta see what is in here. And oh, look at that. Here is a... Yeah, okay, this is the output attenuator. It is that big box there, so this one goes into that one. Interesting. Ooh, we got more of those capacitors. Wonderful. I wonder how we're gonna open these. Can we just take them here? So that was real easy to remove all those nuts, and let's look inside here as well. But from this angle with the better light, it is actually easier to see all the capacitor corrosion, how bad it really is. It's just all over the place. And you can see it here, right? And here's another board, and it's the same. All those capacitors, they just puked all over the place. So this is the RF input connector. I really like all this copper and good shielding and all that kind of stuff. So here we got power input and a little signal relay for input selection. Oh, this is really beautiful. And this is only a 500 megahertz equipment, but it's really built nice. So you got some wires here for some additional features. They just didn't mount this. They could probably go up here. We got some trimmers. So this is for alignment of all sorts of stuff. Oh yeah, we got those capacitors all over the place. Oh yeah. What is that? Tiny little extra board. Wow, that's all the analog amplifiers and stuff. I wonder what is inside that box. That will be the tuner itself. And over here we got a lot of digital, and that's probably what is not working at all, because we don't see any updates on the 7 segments. So probably got some more of those leaked capacitors. Yep, here we go. Not definitely to blame for nothing working here. So what is that? Isn't that funny? It just looks like a capacitor, right? But why is it? What the? What is that? Definitely looking interesting. I'll try and poke a little bit with the ICs here and try and boot it up again and see if it's more alive here. I guess there would be some sort of a reference crystal or something. Well, that is not the case. Where is it? Now we are inside the most holy of the holiest. Of course, here we I don't know if you can see this inside there. I think it's impossible for me to shine light in there, but that is actually a multi-section variable capacitor that is here, and the end of that capacitor is actually that wheel that's connected to that one. And here we go with some compensations. That will be all the different ranges. That is selecting some stuff as well here. And here we got some different variable oscillators. And again, look at those capacitors. They are just totally to blame for all the problems. See? Corrosion all over the place. And of course, those amplifiers, oscillators and whatnot, they're of course not working because we got leakage, all this acid puke all over the place here. It's completely conductive, and that will prevent anything from working here. And this board here is also full of those capacitors, and they just puked all the way here. Look how it's just not so good. Oy, 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 here it's really bad. So of course nothing is working. I was looking for the reference oscillator. Here it is. Of course it is inside here. So that is nice. And this one is connected via a little coax cable to some of the other parts out here, the counter stuff. Yeah. It's really, really sad to see all those capacitors causing all those problems. And it's really a nice unit, well built with all the mechanical solutions here. Look how they soldered little copper standoffs. You know, coax goes through holes and all that kind of stuff. It's nicely hand built. There's some op amps doing some little things here. 83. So this board is from 83. I think that is definitely the date I was looking for. So now we have a date. I saw some other notes written here and there and all over the place. We also see handwritten notes and all sorts of things. See 30, that may be the serial number, right? It's also 30 here. Yeah, I saw some, can't remember where it was, but I've seen a lot of little handwritten notes all over the place. But yeah, I think I know now why this unit is definitely not working. See? Tons of handwritten notes. It's really fun to see all those. Look at all that. Also 83 here. So I think I'm not going to do a lot more now because this is going to be 500 hours to poke around with all those capacitors, and then maybe it's going to work. I don't know. You can see it's just causing complete malfunction all over the place. But at least I've documented the state of this unit, and that is more or less what I came for. I was really hoping that it would have been possible to fix it, but this is not too good. Yeah, so here we go. That is the main clock entry.